How's it going, guys? Welcome back to Design Patterns Episode 4. Today we're going to be talking about the object pool. And this is a pattern that basically helps you a little bit with caching and just keeping your memory aligned, but not having to recreate variables that you've already used. So if something gets reused constantly, and maybe normally you would deallocate a bunch of times. If you want to avoid all those reallocations, deallocations, use this object pool. And with this object pool, basically you're going to create it once, and then whenever you use it, you pull it from the pool, and then whenever you put it back, you just put it back in the pool. And you might reset the memory every time, like, just set it to zeros or to its default value. But before I code up a quick example, I'm going to show you a web page that basically has a great example, and I'll leave a link to this. Of course, with all these patterns, there are tons of links and examples online, and you can find them. Usually you have to search for C++ versions if you want to stick with that, because they're often in Java or Python or something. But yeah, let's take a look at the object pool, get a sense of. So here on this source making, they have this design patterns book. I don't know how good it is. I haven't read it myself or anything. Here's the web page. I'll leave a link down below. And here's the basic gist of it if you want to read it. But it's basically as I explained. It's pretty straightforward. So yeah, think of it as like a warehouse of stuff. If you don't have the stuff, you need to order it or create it. And once you have it, it's in your warehouse, right? So it just exists there, and you can go grab it whenever you want. But once someone is using it, no one else can get it either. So if you need multiple, you got to create more. And when you're done with it, you put it back in the warehouse. So that's essentially it. It's kind of like borrowing from a pool in general. So let's check out Object Pool in C++, see what they got going on here. They're using list, IO, and string. So their resource is essentially just an integer. Here it is. There's the value. They have just a constructor to set it to 0, reset to 0. But it's essentially, the resource is just an integer. And they've wrapped their integer in a class. Yours is probably going to be something else, because an integer is obviously very simple. And here's the object pool. Note that this is a singleton. That's fine. You can see they got a static instance here privately. And as we talked about a little bit in the singleton instance, I noted that this didn't work. But this does work if at the end somewhere outside your class you do this sort of thing. So you basically have to declare it outside the class and initialize it. But you can see they have a private list of resources. And this is resources pointers. Now, you don't want to use list. List is going to scatter your memory. But they're only using pointers, so these little pointers are going to be all over the place. In general, you probably want to avoid using lists. It doesn't put things in contiguous order. They'll just scatter all of your memory. So usually you want to use an array or a vector, but this is a small enough example, it doesn't matter. You do want to use a list sometimes when your object here is huge, but in this case, their object is a pointer, so it's tiny. So you definitely don't want it to be a list. So that's something whoever wrote this probably didn't know or realize, but that's the thing. So you don't want to copy examples exactly sometimes. I mean, you can, it would work, but it's just going to be something that's going to be like, oh, why would you do this? It's bad for your CPU. All right, so here we go. They have the old get instance. We saw this in the singleton, so that's pretty standard. And of course, you want this as a singleton, otherwise you'll be generating a bunch of different object pools. You want one, it's essentially a manager of this stuff. All right, and then you have get resources. So whenever you need a resource, it's going to get a pointer to it, which means, it's just access to the memory that it created. So if your resources list is empty, it creates a new one with a new resource. If this obviously wouldn't compile, because they're not creating the resource correctly. But, I don't think they compiled this code or tested it thoroughly, but yeah, so it goes. Else, if you already have one, if you already have resources available, then they're just getting a pointer to the front resource, which is the very first thing on the list, and then they're popping that pointer off the list and returning the resource. So essentially, you now have the pointer, reduces the size of the list. So maybe this is why they're using list, is because they're using this pop front and front. This is kind of slow in an array or a vector because it has to rearrange everything, I believe. But in a list, it doesn't have to rearrange the whole array. So maybe this is why they decided to use a list, because they're using this method here. All right, and then when you're done with the resource, you call return resource, and it's just a pointer to the object once again. And we call object.reset, which we saw earlier, just sets it to 0, and then we add it back to our list. Now, what's important about this is we're only passing around pointers. So some pointers might be created and deleted, and yeah, and deallocated a little bit, but the actual object itself nothing here calls delete on it. It never gets deleted once it's created. So that's the thing. You don't see anywhere here delete resource. And since this is a static singleton, it's actually okay because statics exist through the lifetime of your program. Whenever your program exits, it's going to clean up all those. However, if this was not a singleton, have to be a lot more careful about memory leaks. But there is another kind of bug here, and that's that it could grow infinitely large. If you just keep grabbing objects, it's going to endlessly grow. So you probably want to have some kind of cap on it, like, hey, I can maximum manage 100 objects or whatever. Because some clever person could be like, well, I'll just endlessly grab resources, and then you run out of memory and you crash. So that can happen in this particular instance. A bit of a naive instance, but it still makes the point. And here we go, just as you would expect, a tester for it. They create a couple instances. They use this pool to get an instance. They create 1, 2. These are nothing's there. They want to turn them into something, so they call get resource. You can call set value on the resource, etc., etc. All right, so back into our code. Now I've already made a new folder for object pool over here. I've made a CMake that's ready to go, and I've made a main that's blank and ready to go. And of course, in our mid-level CMake, I've added subdirectory object pool so that it makes that. So let's go ahead and do this. We'll follow a pretty similar pattern. We're going to have a resource.h to handle that, and yeah, we can do the same thing. In fact, let's save some time. I know I've made these kind of long, so I'm going to try to wrap them up a little quicker here. Sometimes I think it just distracts a little bit once it gets too long. So I'm going to grab this, and we'll just clean up things as we go. What do we need here? I don't think we need anything. Maybe C standard live. Yeah, probably. That's probably it. All right, so we got a resource class. It's private. Privately got this value. We got a set and reset. Now, of course, these could be anything. You're supposed to use this with large objects in general. This is a tiny object, so it's kind of a bad example, but it still gets the point across. So just keep that in mind. So there we have our resource. Okay, let's go ahead and make our manager. I'm going to call this warehouse. All right, I just like that because I like that example. So I'm going to once again copy everything from that, and we'll clean up as we go. So we got our object pool. We're going to have to include a few things. I'm going to leave this list. I think maybe they also made it list because this is supposed to be used for large objects, and list is good with large objects. It's just that in this example, it just happens to not be a large object. So keep that in mind with the whole list and object pool. Large objects. It's for large objects. If you're using tiny objects, probably doesn't matter if you allocate and deallocate them so much. So yeah, I think that that covers most of it there. All right, this looks pretty good for the most part. Let's go ahead and just name this object pool to warehouse. All right, rename all. There we go. There we go. We got privately. There's our resources. We got our instance. So I'm going to move up a little bit. We got a private constructor, and we'll leave this here. Publicly, we got the get instance, so you can get access to the warehouse. A little singleton method there. And here's a get resource. Yeah, we'll leave this create a new return existing. I'm also going to leave this at the top of these, just so there's no confusion. And hey, we're putting our sources up there. Sources are always good. Example derived from, here we go. Boom. Boom. All right, good enough. Looks good. Yeah, we'll use this front. This is fine. There's an error here though. They do need to put. Oops. They just select all. Okay, yeah. When you create your new resource, you need to make sure you have these for your constructor. And you could even do some. This could be a factory. You get resource, call factory. There's a lot of things you could do. You could essentially turn this into like a warehouse that is also kind of a factory if you want. There's you can be creative with these for and go with what your program needs. All right, and then we got return resource here at the end. So basically, instead of create, or new and delete in general, you're going to call get resource and return resource. And yeah, I guess that's about it for this little warehouse. So let's go into our main here and let's go over their example. I'm just going to copy and paste their example in here. Let me check one more thing on this warehouse. Okay, yeah, we got the static instance at the bottom, so that should be good. Initializing to 0 is the same as null pointer. I generally like doing null pointer because I think it's a little more clear, but they're the same thing. Some compilers will complain if you don't put in the right one. All right, back to our main. Let's have a look here. And obviously object pool we renamed to warehouse. So let's go ahead and do that here too. I'm gonna hit, oh yeah, we got rid of the main here. Let's clean this up real quick. There we go. There we go. There we go. Well, we need to include our warehouse. And warehouse needs to include a resource. Yeah, I think we're good. I think we've explained most of it. Let's go ahead and give this a run. Give this a run by changing this to object pool. Hit play. Let's see if we get any errors we need to fix. Nope, looks like we're good to go. And yeah, there we go. Seems to do what it's supposed to do. And you can see they put the memory addresses in here, which is great. You can see the first one has this memory address. Let's look at the last few digits, 6E0. And when it returns it, it stays the same memory address. So that's important. The object is staying the same. We're just essentially passing around pointers to it. So we can walk through this. Yeah, here we create a new, or we get the instance of the warehouse. We're going to need that to work with. We create a couple local temporary resources, and we gather, and we have our pool create those. And we can call the set value method, and this cout is just the demo. We got the value, it should be 10, and this here is the address. Since this is a pointer, it's going to be the memory address. And then we do the same thing with the second one, so to a different value, check its value, check its memory address, and then we call return resources. And then we do the same thing once again. And we basically just check that they're reset, but it's reusing the same space and memory. As you can see, when you get them again, they're reset, but they're the same memory location. And that's basically it. There's not a whole lot else to it. This example could get a lot more complicated. A lot of things are churning in my head about things I want to over-explain, but I'll probably just end up making it more complicated if I do. So I'm going to leave it at this. Let me know if you have any questions about the object pool. I believe I've covered everything, at least in theory, and talk about what you need to do and know. All right, thanks for watching. See you guys in the next one. Keep coding. Peace out.